Hello, welcome to this tutorial on how to build an iOS plugin for Unity. We're using Unity 27.13.3. We're in 64-bit mode and running on a Mac. So this is a brand new project. It's got zero content. So let's just make a few bits and pieces before we get started. And this is just from my own benefit, our own preferences. I like to organize. So I like a scripts folder, a scene folder, and then this next is required. So we need to make a plugins folder, and this is where Unity will look for, and it has to be called plugins. This is where Unity will look for our iOS plugin, and inside plugins we're going to make a folder called iOS, and so this is where our plugin will reside. But before we start any coding, let's just a few more bits and pieces. We'll create a 3D cube. We're going to switch from, right now this is in PC Mac, which is the Unity default, and we're going to switch to iOS mode. So we're going to bring up build settings, click on iOS, switch platform, and if there's nothing in the project, this is pretty quick. If there's a lot of assets in the project, this can take some time. Okay, and then other thing we want to change is in the player settings, under iOS, we're going to scroll down here, and what we're going to do is switch so we can use the simulator. So right here we've got device or simulator SDK. We're going to select simulator SDK. Device SDK is the default setting. So we're going to create some script files first. Now we're going to have just a trivial script that rotates the cube just so we can see that the Unity scene is running on the iPhone. So let's create a C# script, and we will call it spin cube. And we're also going to create another script. This one we're going to call plugin test, and this we're going to use to call our plugin code, so we can see that it's running as we expect. Okay, so we're all compiled up, so we'll put plugin test on the main camera, and you can see the script is now here, and on the cube we're going to put spin cube. Okay, and one other file I want to create is inside the iOS folder. I want to create a file, and right now we're going to call it, it's going to be a C# script, and we're going to change that, but for the moment we're going to be a C# script, and we're going to call that my plugin. And we will get rid of all this and everything else in a bit. We're going to rename this file, so let's show it up in Finder, and here it is .cs, and we're going to change this to .mm, which is an Objective-C type. And then if I double click it, it will open up in XCode, so we can get rid of all this code because we don't need that. So now let's start adding some Objective-C. Okay, that's going to be our base import statement that will let us use NSObject as our base class. What we're going to do here is we're going to build an object that uses NSObject as its base class, and it's all going to be in one file. So instead of having a separate header file, it's just going to be one file. And the reason for doing that is it makes it easier to maintain whenever we're making changes. Okay, so we did an interface, which is the header, normally the header declaration, and now we're going to do an implementation. So we can use this little doohickey down here and just drag our implementation tag here, and let's call this again my plugin, and then we're going to define some methods. So because we're going to use a singleton method, that means we're needing a reference to our object that only gets created once. And once again, there is we're going to create a static method which returns the plugin. We're going to call it shared instance. So this method will create the plugin if it doesn't already exist. And if it does exist, it's just going to return a method. So that's dispatch once code, an XCode template. So here, let's put in some logging. So this is a standard instance, a standard singleton instance approach. And we're done, and then we're going to return the shared instance. So XCode, our iOS will only call this once. Once it's been called, then the shared instance has been created, and we'll just return a reference to it each time. The last thing we want to do here at this point is create an init method. And once again, you should be familiar with this. This is the standard ObjectiveC init pattern. And there is a shortcut over here you can drag and drop, but it's really not very complicated. So, and then I like to do this. So we're going to call this method init helper, which is our custom method that will be called whenever the object's initialized. So instead of filling additional initialization code into this, I like to have an init helper. That way, if we have additional init methods that we add at a later date, they can all call back to init helper and set the thing up the same way. And so at this point, all I want to do is just throw in a log message, just so we know it's been called. And that's it. That's the basic plugin. Pretty simple. All it does is create a copy of itself, and then we can refer to it anytime with shared instance. So go ahead and save that, and let's come back to Unity. And so now you can see the plugin icon has changed. Now it knows it's a plugin because it's a .mm file, and it's a native type. It's iOS, so you can tweak this to include for other platforms. So if you did want to include it for tvOS as well, you could do. And then these are additional frameworks that can be added in. We don't need any of these at this point, so we're all good. And that's it. So now we've got our plugin set up, and we're going to make a build to iOS. First thing we want to do is save this scene, though. And let's just call it plugin test and put it in the scenes folder that we created earlier. Okay, and then we're going to build it. So we're going to file, build settings. Once again, we're on iOS. We've already set the player settings before, so we're going to hit build and run. This is going to ask us for a folder in which to build an iOS project. I always use the same folder name in every project just so it's easier to track them. Plus, I can add that ignore. I can ignore this folder in Git so I don't make a copy of it and make my repository way bigger than it needs to be. So I'm going to shortcut this. Now we've got the project built, and XCode has automatically loaded the project and has also cleaned and built it. So we're good to go. If you want to look at the plugin file, it's going to be here under plugins, iOS, my plugin. And then this is the code that we wrote earlier that's been copied from the Unity project into the iOS project. So if we pop the Finder, so what we can actually see here is we've got our iOS build folder, and then in our libraries, plugins, iOS, and here again is this file, which is the same as this file. So this file gets copied forward into the iPhone project or the iOS project. Key to remember is if we edit this, we need to copy it back into the Unity folder so that next time we build, it gets copied, because this will get copied over again. So any changes we've made will be overwritten by this file. So it's important to remember to copy forward any changes. Okay, so this is our iOS code, and at this point, nothing is calling this, is making this happen. But we can go ahead and run it, and it's, as you remember, we set this up for the simulator, so it's going to build it to the iPhone simulator. And here we go. So the code's running. I don't think there's anything that happens. Yeah, so we just got our static cube, no additional information here. So back to Unity, and we will fix some of our, add stuff to our C# scripts that will let us both spin the cube and actually start our plugin testing. So the cube spin is pretty trivial, as you would expect, assuming you're familiar with Unity. Let's just throw in, and I'll speed through this. Let's do this. And this will make our cube spin. For plugin test, going to be a little more complex, and this is where we're actually going to start calling back into our Objective-C code. Now at this point we don't have a hook into the Objective-C code, but that's what we're going to create here, and then we need to add it into the plugin class in order to call it back. So what we're going to use is an attribute, DLL import, and it's just a little magic sauce, and private static, and we're going to add this function, and this is just a trivial example that's going to return the amount of time that's elapsed since the plugin was created, and it's going to return that as a double, and like so. Now in order to fix this, we need to import system interop services. Another thing is, because we can write code that runs on multiple platforms, we want to wrap this with a Unity iOS define. So this will only be available if we're running on iOS, which is what we want. And then in our start function, that's going to be a double, I'll just call it get elapsed time. And once again, we're just going to return the iOS get elapsed time. That's it. This is going to return the time that's elapsed since the plugin was created. Initially, it's going to be a 0, but on subsequent calls, it will be the amount of time elapsed. So let's do a debug.log. Okay, now here's a few other little tricks. So we want to make sure we're actually on, once again, you got to assume multi-platform. So we want to make sure we're actually on an iOS, an iPhone player. So runtime platform.iPhone player. So if we're on the runtime, if we're on an iPhone player, then this will get called and return the right value. Otherwise, let's just put up a warning. And return 0. Okay, return 0. So now if this is running on anything but iPhone, it will not try to call this code that won't exist. And so we'll not get a problem, but we will get a warning as long as we're on the wrong platform. And we'll get a 0, just like we should get here too. One last thing is here, let's call this every 5 frames. So we'll do let's do a frame counter, and we'll set it to 0, and then increment it. And if it's greater than or equal to 5, what we're going to do is debug.log. Let's take plus get elapsed time, and then set the frame counter back to 0. So every 5 frames, we're going to call into the plugin and see how much time has elapsed since the plugin was created, print it out with the word tick in front of it. And that will just repeat forever. So if we go back into Unity and run this, once it's compiled and we run it, we just get our spinning cube, we get our zeros on the wrong platform, and that's all we're going to get, and that's going to keep repeating because this is not on an iPhone. Okay, so in the Visual C code, in the C# code, we're calling this function, which currently doesn't exist. So we need to create this function. We need to create this function in the ObjectiveC plugin code. So let's go back to Xcode, and then this is our plugin. And outside the plugin object, we're going to use an extern C scope. And this just means that these are functions that are wrapped in a C declaration that the DLL import can find. So it's a little bit of magic sauce, but it just makes the whole thing work, and it's important. So what we need to do is give it we need to create our function, double, and then we called it iOS elapsed time. We have no parameters, and this is going to return the value from the plugin method. So we're going to do my plugin shared instance, and then get elapsed time. So this is going to return the plugin object, shared instance, which first time it's called will actually create the plugin object, and then on subsequent calls it'll just return it itself. So we need to add a method to the object, which is also going to return a double, and that's going to be get elapsed time. And this is pretty simple. We're going to return an NS date. We're going to get the current time, and then time interval since date, and then we need a new variable called creation date. And then creation date is going to be when we create the plugin. So this is where we use our init helper. So we do creation date is going to be equal to ns date. So that's just going to get the current date when the plugin was created. And if we come up here and actually create this variable, so this is ns date star creation date. So this is the variable that this is going to refer to. And now you start to see why we're putting this as an object. Here's a persistent piece of data that we want to exist outside of Unity scope, and we don't want it to be thrown away, and we certainly don't want to try to reinitialize it every time because it wouldn't make any sense. So by creating an object that is persistent, it can have variables that are persistent, attributes that are persistent, which we can then use in our code. So this will get the elapsed time, which will return the difference in time between our creation date and our current date. And there we go. So that's our plugin code. Now, this, once again, we're editing the version that's part of the Unity assets folder. If we were editing the version in the code in the iOS project, and here you can see these edits are not been copied forward yet. This would be overwritten when we build from Unity. So let's switch back to Unity. Okay, so we switch back to Unity, and we have updated our C# code, and we've updated the spin cube. And we have also updated the plugin, although you can't actually see the text here. So we're going to go ahead and rebuild the project again. This time I've used Command B, which just does build and run behind the scenes. Because we've already put a folder name in, it will rebuild over the existing project. So now we're looking at Xcode, and as you can see, the code in the project My plugin code has now been updated with the edits we made earlier. So Unity has copied forward the MM file into the project. And this is what it's building and running. So let's bring up the simulator, and we'll also switch to the debug output so we can see what's going on. That's the Unity code has now started, and it takes a few seconds to figure itself out, but now we can see it's running. We can see we're getting a tick count every frame, every 5 frames or whatever. And if we scroll all the way back to the start, it actually took, so this is effectively 0, but then it was another 7 seconds before the first frame executed. Here you can see the log file, the log entries, where we created the shared instance, we created the helper, and it was called. That initial elapsed time was 0, but then subsequent, it was like another 7 seconds before we got our ticks going. And then you can see the ticks are happening consistently thereafter. And that's it. So our Unity code is calling this every 5 frames, which in turn is calling into our object, which is referencing a object variable property. And this has only ever been called once. In subsequent calls, it's being returned just the pointer to the object in question. And this means we're not recreating the object, we're using it once, and everything is working as you would expect. So that ends for our tutorial. It's pretty simple, it's pretty basic. The next thing I'm going to do in the series is put in calls to native alerts. So you can actually call an alert dialog within Unity that's native on iOS. So hopefully you've enjoyed this, hopefully you've learned something, and see you next time.